Becoming a games programmer is exciting, it's challenging, it's extremely satisfying, and you'll find it to be incredibly rewarding, but where do we even start considering how many options are available to us? To help us make sense of it all, we can consider each and every one of those options to belong in one of three distinct categories, but what is the true nature of the programming style for each category and which one is the best option for you? Option 1 is to learn games programming by using a games programming library such as Allegro or SFML. Both of those libraries are very popular for learning 2D games, and you'll be using C++ as your programming language, which is still widely regarded as the fastest, most powerful programming language in the world for creating games. If you choose either of those programming libraries, then you'll be writing C++ code for all aspects of your game, which includes character control and animations, game physics such as collision detection, and various other important aspects, so you'll be learning how to program your game at the same time as learning C++. This is a glimpse of the code from my Allegro Pac-Man game. I'll show you some of its cool features in just a second. Your code will start off like this by including the various Allegro header files. You'll need to declare some of the game variables. You'll see that I've created quite a lot of my own functions, but I don't have any of my own classes. I'm just using C++ structs instead, which is good enough. This is the main loop, and then we free up the resources when we exit the game. This is the function that kicks everything off, and then all the really cool stuff happens from here by calling all of my other functions. I think this is really awesome. You can draw your own mazes, which you get to play as a bonus level. You need to analyse them first to make sure you haven't messed up. The game speed also gets faster as you progress through the levels, and the ghosts move really fast if you eat too many, and if you scare them away off screen, it makes them mad as fuck. So using games programming libraries is cheating a little bit because they take care of the so-called graphics pipeline for you, but that doesn't diminish the significance of what it means to control how everything works at the heart of the code. Both Allegro and SFML are 100% free, meaning that you can make an unlimited number of games, charge as much as you like, and you'll never have to pay any kind of license fee or royalties. Option 2 is to learn 3D games programming by using an API such as OpenGL or Direct3D, both of which also use C++ as your programming language. If you do choose to learn a graphics API without having any prior programming experience, then you are jumping in at the deep end, but that doesn't necessarily mean that it's the wrong choice for you. This is a block diagram of the graphics pipeline, but in all honesty, even just a basic understanding of only a few aspects of all this is more than enough to get you started, and you'll be developing a good understanding of how graphics rendering works under the hood. By using OpenGL or Direct3D, you'll be working with things such as transformation matrices to control the size, orientation and position of your models in 3D space, and programming your own shaders. For example, by using the GLS shading language that we use in OpenGL, you can make this happen programmatically directly inside the vertex shader. To add audio to OpenGL, you can use OpenAL Soft, which I've already made a tutorial about, and for Direct3D you can use Microsoft's Xaudio 2. Both of these graphics APIs and both of the audio options are 100% free. I've managed to create this RC simulator with OpenGL just by learning the very basics of what OpenGL is capable of. One of the things you'll really like about using a graphics API is that you'll have total control over how everything works because it'll be you that's writing all of the code. There are also some low-level options available, such as Vulkan, DirectX 12 and Metal, but I'll talk about those another time. Option 3 is to learn how to make games by using a game engine, such as Unreal Engine or Unity. I've been playing around with Unreal over the last few days just to give me an idea of what it's all about, and I've decided to add it to my list of tutorial topics for future videos just because of how much fun it is to play around with. It's way different from anything I've ever done before. My model gets loaded into the scene and I can move it around with the keys and control the camera with the mouse, start and stop the engine, and it's all done purely by using blueprints. I'll just very quickly show you a few things that you need to do. You need to import your model by selecting import from the menu. These two input action files, you literally just need to create them, again by selecting from the menu, but you do need to set up the user input in the input mapping context, which looks like this. Double click on your model to open it, and in here you can make some basic changes such as scaling, rotating and changing the position, but any major changes should be done in your 3D modeling software before you import your model into Unreal. When you compare all that to OpenGL, for example, you've got an appreciable amount of programming to do yourself to get a model loaded, even though you'll be using a model import library such as a simp. Adding a camera is as easy as selecting it from the drop-down list, but there's this strange thing called a spring arm that you need to associate with it to make it work. You can then either run it inside the editor, or you can build it as an independent executable that you can share with your friends, or when you get really good at it, you can start making games and sell them online. I've also managed to add a skybox to this example, as you'll see in just a second. It's mostly just a matter of loading the HDRI by selecting import and then changing a few settings. There's loads of other stuff that's done for you as well, so that you don't have to programmatically do it yourself. For example, there's the lighting, creating shadows and spawning new objects into the scene. This is just another one of my beginner efforts for me, because I'm only just starting to learn about game engines myself. So the developers of game engines have already incorporated into the engine APIs such as OpenGL and Direct3D, so that you don't need to understand the graphics pipeline in order to create games when using an engine. So I've shown you blueprints, but what about adding your own C++ code? Whenever you create a new project, you simply select either blueprints or C++, but even if you select blueprints, you can still add C++ code anytime you like. Just select to add a new class from the Tools menu. Another awesome thing is that you can have a mixture of blueprints and C++ working together, which apparently is what most experienced developers do anyway. For example, these spheres are being spawned into the scene by using these few lines of C++, which under the hood then tie in with these blueprint nodes. You might be thinking, what's all this going to cost us? Well, it's not really. Unreal does require you to pay a 5% royalty fee for any particular game, but only when that game earns you over $1 million US.
But you'll be rich by then, so who gives a shit?
But which is the best option for you? The answer to that question largely depends on what matters to you the most. Either making games with cool graphics as quickly as possible, or learning how things really work at the heart of the code. Keep in mind that automated functionality in game engines, as incredible as it is, can still leave you feeling somewhat restricted. Think of it as selecting options, pressing buttons and twizzling knobs, kind of like playing a game to create your own game, and so you're being restricted by the rules of the game engine. Having said that, the more you get used to incorporating your own C++ code, the better overall control you're going to have. One thing I would say is don't bother trying to write your own engine by using an API. Imagine for a moment that you've made the effort to create your own engine to help you make games. It's not going to be on the same planet as Unreal or Unity, and if you decide to use an API instead of an engine, you'll still end up with loads of classes and subroutines that you can reuse as you create more games.